Imagine managing a sprawling corporate network with thousands of employees. Trying to manually assign and track individual file permissions for every single user creates a massive administrative burden. Looking at this swarm of isolated glowing nodes, you see the reality of an unmanaged system, data and users moving erratically, colliding without central structure. To establish order in this chaos, a system administrator relies on a group account, a unified collection of user profiles that share the same access rights. Linux handles this in two ways. First is the primary group. This is an automated shadow created the moment a standard user account is born. Second is the secondary group. This is a custom-built collective, created manually by an administrator to consolidate permissions for specific tasks or departments. Secondary groups provide the framework for managing access in bulk. By grouping users together, permissions can be assigned once to the collective rather than repetitively to every individual profile. We begin by initializing a new restricted access tier for a specific department. For our example, we will build a target collective named IBM GRP. To create this new structure, we execute a single terminal command, groupadd IBM GRP. Linux terminal operations are typically very silent. When you press enter, the lack of visual confirmation means you must manually verify that the group was actually created. You verify this by using the grep command to parse the system's central group database, located at /etc/group. This terminal interface displays the /etc/group database output. Scanning the text, the highlighted string shows our new IBM GRP entry. Locating this entry in the central database confirms that your new group is recognized by the system and ready for use. Now that the empty group is verified, the next phase is populating it with active user accounts. To add a single user into the collective, use the command gpasswd-a, followed by the user's name and the group name. To remove a user, swap that flag to a -d. This severs the user's connection to the group's permissions. This diagram shows the basic flow of membership control at an individual level. The central hub pulls a single floating node into its perimeter and cleanly severs a connection when a node is removed. However, adding dozens of team members one by one is slow. To speed this up, you can use a bulk addition command. The -m flag allows for bulk membership management. Typing gpasswd-m, followed by a comma-separated list of users, applies them all to the group at once. Watch what happens to the central hub during a bulk addition. It drops all of its existing node connections before the new cluster attaches. The -m flag does not append names to the existing list. It is an overwrite that removes any current unlisted members from the group roster. This demonstrates how a single command can significantly alter system access, making it essential to understand how a flag behaves before execution. As a system grows, a root administrator may need to delegate the responsibility of managing specific group rosters. To do this, you can elevate a standard group member into a group administrator using the command gpasswd-a. For security, the Linux system does not list these administrative properties in the standard /etc/group file. To audit who has administrative power over a group, you must access a separate secure ledger located at /etc/gshadow. You verify this newly granted authority by running the grep command against that shadow file. Segregating administrative privileges into the shadow ledger prevents standard users from easily mapping out the system's command hierarchy. We can now apply our group structure to a tangible asset, a directory named chown. First, we use the command ls-ld to audit the target directory's current permissions and see who currently owns it. Changing these permissions is like engaging a vault lock, restricting access to everyone except those we specifically designate. To change the directory's group ownership to our new IBM group collective, we use the change grp command. If we need to update both the individual owner and the group owner at the same time, we use the change own command. This logic map shows the directory now protected by two specific perimeters, one for the individual owner and one for the group collective. Linux groups function as logical containers. By linking users to these collectives, a single permission update on a directory applies to every member of the group, keeping the server's access structure organized as the user base grows.